Okay, 5.2 is addition and subtraction of polynomials. So the first thing they do is they kind of look at a basic definition of a polynomial. And essentially this is it. And 3x to the 7th minus x plus 7. And essentially what you're looking at is, if I'm looking at a polynomial, this is something that has to occur. First of all, if I'm looking at a polynomial, is that the exponents are whole numbers. And you say, well, what's a whole number? What a whole number is 0, 1, 2, and so on. So in other words, I won't see anything as an exponent other than a whole number. No negative numbers can be an exponent if you are a polynomial. Okay. They look at things in a polynomial, and by the way, this guy is in what we call descending powers. Descending powers of the variable. So what you notice is the highest power comes first, then the next highest power. And this guy has no power at all. Okay. So it's highest power to lowest power. That's what they mean by descending powers. Okay. Now, what polynomials have also are things called terms. And they say terms are separated by additions or subtractions, or pluses or minuses. And what these really are additions and subtractions. And so what that means is, it's like and or ors. So I look at it, here is a term, subtract, a term, add, a term. So this guy has 3 terms. Three terms. Now polynomials also, each term has something called a coefficient. And I look at it is, and what is a coefficient? And see, all of these things should be in here. A coefficient is a number that multiplies a term. So I look at 3x to the 7th, the coefficient is 3. Here the coefficient is -1. So it picks up that negative that's in front of it. And this guy doesn't have a coefficient. He technically, you can say, if I'm looking at 7, he could maybe be 7x to the 0 power. X to the 0 would be 1, right? So he really, technically speaking, doesn't have a coefficient. Now, all polynomials have something called a degree. And a degree of a polynomial is the highest power of any term. Highest power of any term. So we could take a look at it. What's the highest power you see? 7. This sucker is degree 7. He is degree 7. And if you're going to take college algebra, which is probably where most of you are headed next, if you're going to take college algebra, then you're going to find that the degree gives you information about that polynomial. So we use the degree to tell us stuff. Okay. Now, if the highest degree of any term, then how do we find, well, let's go back. How do we find the degree of a term? Now, the degree of the term is the sum of the exponents in that term. Now, in this class, we really don't have to worry a whole lot about this. And in fact, in college algebra, we don't worry about it either. But unfortunately, your book does do that. In fact, the problem number 2 that we're going to work actually brings that into account. Now, the other thing that we need something called the leading coefficient. And what's the leading coefficient? It is the coefficient of the term of highest power. It's the coefficient of the term with the highest power. So in this particular instance, you notice they've marked it. The leading coefficient is 3. The term with the highest power is 3x to the 7th. The number multiplying that is 3. He's the leading coefficient. Leading coefficient, I'm going to use that a lot in this chapter. So it is the coefficient of the term with the highest power. Okay. So this guy is degree 7 with a leading coefficient of 3. So here we go. This says determine the degree of each term. Well, the degree of 16x cubed is degree 3, degree 2, degree 1, degree 4, and this is really x to the 0 power. A constant is degree 0. So what's the degree of this polynomial? 3. And what is his leading coefficient? 16. Now this is where that screwy definition comes into play. And I'm going to kind of put little marks between each term. The degree of the term is the sum of the coefficients. So this is or sum of the exponents. 4 plus 2, this guy is degree 6.
Wait, number 1 was the degree before.
Yeah, the division before.
4 plus 2. It's the sum of the...
Number 1.
Oh, I'm sorry. Oh, dang it. Oh. I wasn't paying attention. And 3. Are we okay now?
Yes.
I hope so. Thank you. See, that just tells you you're paying attention. Woohoo! And 2 plus 5 is 7. Oh, here's another term. What's the degree of 2? 0. It's a constant. And 1 plus 1 is 2. So what's the degree of this polynomial? 7. And then what is the leading coefficient? So degree and leading coefficient is going to play a big role. Most of the time, what's going to happen, however, our polynomials will only have one variable. They'll only have one variable. Add and subtract, adding a polynomials, add and subtract. To add or subtract two polynomials, we combine like terms. Remember, two terms are alike if they each have the same variables and corresponding variables are raised to the same power. When I think about adding like terms, this is what I think of. If I had a 3x squared and a 4x squared. You can say they're like terms. Well, how are they like terms? If I circle everything but the number, are the two circles identical? Yes. That means they are like terms. So I can count. I'm counting circles. 3 circles plus 4 circles is 7 circles. That just happens to be an x squared. If they are not like, I could say a 3x squared and a 4x. Now, if I circle, I notice, are the two circles the same? No. So I can't combine them. So if I circle everything but the number and are the same, it's just like adding how many circles I have. Or subtracting how many circles I have. But if they're not the same, this is going to be true for everything we do for the rest of the semester. If they're not the same, then you can't bring them together. That's the key. Circle everything but the number if you're in question. If what you've circled is identical, you can bring them together. If they're not, you can't. Period. So here we go. What this guy really is removing parentheses and combining like terms. But here is a 1 multiplying this parenthesis and a 1. Anytime you multiply by 1, what does it do? Clear everything, and no sign changes, right? So this becomes 9 n to the 6th plus 4 n to the 4th minus 5 plus 3 n to the 6th plus 2 n to the 4th plus 8. And now I look for like terms. Here's an n to the 6th, here's an n to the 6th. I have a 9 n to the 6th plus 3 n to the 6th. And then there's an n to the 4th and an n to the 4th plus 4 n to the 4th. And yes, you could do this in your head if you wanted to. 2 n to the 4th. And then I have a negative 5 and a plus 8. So this gives me a 12 n to the 6th, because they're the same, plus 6 n to the 4 plus 4 is 8, minus 3.
So you do change your sign, 6n to the 8 and 4 to the 8 to the 4.
Oh, dang it.
Wait, what?
It's to the 4th.
Where?
Here.
Oh, yeah.
I'm going to be glad that I'm going to redo this note packet so I can re-video it.
And then it should be plus
How is
3.
it?
Oh, go away. You guys just go away. She might as well hang it up today, right?
Like,